Hello, everybody, and welcome back to Gunthrek Chats. I was watching Matt Lown do an episode of Kerbal Space Program, one of his older videos, and he was taking a space station to Joule to do some science there. And while he was doing that, one of the things that he did during the episode kind of made me have a weird thought about the strange way that traveling around the solar system works, and some of the things that we do in our modern times to make that happen, and some of the things that might need to be compensated for in the future that might require some kind of external traffic control. We'll talk about that more in a bit, but before I can do any of that, I do need to kind of do a basic rundown of what a gravity assist is, why we use it, all of that kind of stuff, because if you don't understand how it works, my weird idea is not going to make any sense to you. So to get started, let's talk about what a gravity assist is in the first place. What we're trying to do when we're using a gravity assist is we're basically trying to increase or decrease our speed and change our trajectory from one vector to another. A vector is basically just the direction that your vessel happens to be traveling in. You don't really need to understand any more than that. It's just the direction you're traveling. You're changing your vector. So the reason why that's important is that to get to certain places in the solar system can be very fuel expensive, because changing the way that orbits work is that it's all based on speed. How fast are you going around the sun? The faster you're going, the further out, the bigger the circle you're going to make, because the gravity's pulling in on you, your speed is pushing against the gravity. So the faster you're moving, the further away from the sun you're going to be. So if you want to get to a planet that's further out in the solar system, you basically just need to increase the speed at which you're going around the sun. All right, why is that important? Well, to get to a planet that's far away, we have to increase our speed, right? Well, how do we do that? Today, we do that with rockets and all of that kind of stuff, but a much more efficient way of doing it is to use the gravity of the various bodies in the solar system to kind of slingshot us towards where it is that we're going, or reverse slingshot us by slowing us down and bringing us closer into the sun. Okay, so that's what a gravity assist is. Let's talk for a second about how it actually works. Now, I'm not a physicist, I am not a scientist, I am not an astronaut. I have only a basic understanding of how this works. I will not be able to answer any kind of fundamentally technical questions. I just have an idea of how the concept works, and if you have any more questions about that, you're going to have to go look it up on Wikipedia or something like that. But the basic concept is, as you can see, that in the image here, we see two different things that are called frames, right? So a frame in this context is basically levels at which you can see things. Okay, so from the planet frame, it looks like we're just kind of falling into the star or falling into the planet that we're approaching, right? So we're falling into the planet, we speed up, and then as we leave the planet, it appears like we slow down and maintain our speed. Now, the cool part about all of that is that the planet itself is actually moving in relation to the sun, right? So it has a certain speed associated with it. So as we approach it and we fall into the body or the planet or whatever it is that we're trying to gravity assist around, when we get to the very bottom of that, we are actually moving at the same speed as the planet is moving, right? So we've gained a little bit of speed by accelerating into that. And then as we leave, from the planet's perspective, we fall into the planet and then we go back out. And from the planet, if you're sitting on the planet, it looks like you just fell in, passed by, went back out, and you're going the same speed. But because the planet is actually moving through the solar system, there's some acceleration that happens there with reference to the sun, right? So from the planet's perspective, it looks like you just fall in and come right back out, and you're going the same speed. If you're looking at it from the star's perspective, though, you fall in and you actually pick up some speed because the movement of the star adds on to your movement and shoots you further out into the solar system. And if you reverse that process, it does the same thing. The gravity actually slows you down because you're going in a way that's causing you to slow down rather than slingshotting the speed up. All right. Why is that important for what a random idea? Well, one of the weird things about physics is that for every action, there is an equal and opposite reaction, right? So what does that mean? It means that even a small spacecraft, when it goes through a planet's gravity well, is going to transfer momentum of some kind. If you're trying to speed up, you're going to use the planet's gravity to speed up. You're going to increase your momentum by taking some of the momentum from the planet. completely minuscule, almost unnoticeable, completely unnoticeable amount, but it does happen. You do take some of the momentum from the planet. You are like infinitesimally small amount of reduction of speed to the body because of the just massive, crazy differences in size. But you're slowing the planet down when you're increasing your speed by stealing some of the momentum from the body to slingshot you out. And when you're going back the other way and you're trying to slow yourself down, you're imparting momentum to the body to slow yourself down. So you're giving up some of your momentum and transferring that to the body. Now, the reason why all of that matters, and you can take a look at this other graphic of some of the different ways that gravity systems work while I talk about this next part. The reason why the reason why all of that matters and why I went through all of that first is so that you can understand this crazy, ridiculous idea that I had. We have air traffic control in our aviation today to make sure that when planes and aircraft and other things are all flying around, they don't crash into each other and, everybody gets where they're going in a safe and efficient manner. And obviously, when we get into the future and we start having some serious space travel where, more than just official people and just a few flights are out there doing stuff, you're going to need to have some kind of traffic control out there managing everybody moving so that they don't hit each other. But one of the things that I don't know that I've ever heard anybody talk about is what happens if we start getting so many spacecraft out there that maybe too many spacecraft visiting the same body too many times in the same direction actually starts to measurably affect the trajectory of a planet or a moon or something like that. I wonder if in the future, one of the functions of space traffic control is going to be monitoring the trajectory of these bodies and kind of determining people's flight paths and making sure that not too many people are going on the same flight path and, building up this transfer of momentum too much in one direction and causing problems. Because I don't know. I don't know how many flights it would take to measurably affect even a small moon using gravity assists and things like that. But it's an interesting thought experiment and something to think about. So, I thought, in addition to the various, complex calculations and things that a traffic controller might have to do in the future, or AI or whatever it's going to be, add on monitoring transfer of momentum from spacecraft bodies and the other way around and seeing where the trajectories go. Anyways, sometimes I just have weird random thoughts like that, and I figured that's what my Gunthrek Chats channel is for. It's for talking about the random things that come up that I feel motivated to talk about. So there you go. Space traffic control, monitoring the trajectory of bodies and our effect on them, assuming we put enough spacecraft out there to actually measurably do that. I don't know if that's even possible, but it was a thought, and I thought I'd put it out there. So, thanks for watching. Be sure to click the like button, subscribe to help us reach our first 1,000 subscribers for this channel. Head over to the gaming channel. Check out the several thousand videos I have over there already with various different games. And, thank you very much for watching, and I'll see you for the next video.